It all started with a simple question. Why are car manufacturers moving to fuel injection on gas engines? See, fuel injection has been around on diesel engines for at least 100 years, because a diesel engine relies on a precisely timed squirt of fuel to operate. A gas engine relies on a supply of fuel and a precisely timed spark to function. Ever since the invention of the gasoline engine, a real simple device has been used to provide the fuel, a carburetor. Here's the basic idea behind carburation. A fast-moving stream of air passes a small nozzle, and the fast-moving stream of air creates a low pressure near the nozzle. That sucks the fuel out. Because the nozzle is small, the fuel enters the airstream as tiny droplets. By selecting the correct size nozzle, the mixture of air and fuel can be controlled. The exact mixture of air and fuel used to be merely important, but with the addition of catalytic converters for pollution control and new gas mileage regulations, the mixture of air and fuel has become extremely important. That mixture, if you care, is a ratio of 14.7 parts air to 1 part fuel. Now, because of the pistons going up and down in their cylinders in an engine and the action of the valves, the engine actually acts like a great big vacuum cleaner, sucking air in and blowing it out. It's that incoming stream of air that passes through the carburetor and have fuel added by the nozzle. The carburetor works effectively at highway cruising speeds, but in other situations it gets messy. During starting, the engine needs a little bit more fuel, so a plate's rotated to make the engine suck harder against the nozzle. This is the famous choke. That's a good name for it. The choke releases when the engine warms up, usually. The other situation that requires more gas is acceleration. In actual fact, when you press the accelerator pedal, you rotate this disc, allowing the engine to suck more air-fuel mixture. Now, this alone won't speed up the engine. See, when the throttle plate's partially closed, the engine's sucking against a restriction. There's quite a bit of suction, or vacuum, in the intake pipes to the cylinders. When your foot opens the throttle plate, that vacuum level drops. The small hose connected to the ignition system uses that drop in vacuum to make the spark plugs spark a little earlier. Now, at that moment, the air passage is fully open, the spark timing is increased, and the engine will speed up gradually. See, until it sucks more air by speeding up, it won't suck more gas, and it needs more gas to run faster. The Catch-22 eliminator is the accelerator pump. This little devil squirts an extra burst of fuel down the hole when you stomp on the gas pedal, giving the engine the fuel it needs to accelerate. The accelerator pump will also flood the engine with too much fuel when you stomp on the pedal repeatedly. That's the basic carburetor. It's just a nozzle to meter fuel. And everything else here is added to make up for situations when the engine isn't going down a flat highway at a constant speed. With the increased importance of maintaining a correct air-fuel mixture, it's getting just a little complicated and a little expensive. Let's start over. The engine's a big air pump, and all we have to do is squirt a mist of gas into it to keep it running. That's an injector. Liquid fuel is provided to it at a constant pressure. When an electric current is supplied, an electromagnet opens a valve and the fuel squirts out of a tiny hole. The injector is an on-off device. It either squirts or it doesn't. But by pulsing it on and off rapidly, the amount of fuel it squirts is adjustable. Here's one way to replace the good old carburetor. This unit goes on the air intake of the engine. Now there's still a throttle plate in the airstream controlled by your foot. This thing regulates the fuel pressure so that the only variable is the length of the squirt. The squirts are pulsed at under 1,000th of a second, and so it appears as if the spray is constant. And if you haven't already guessed, the injector is controlled by a computer. Had to happen, didn't it? But as long as we have to have a computer, we can give it all sorts of interesting inputs. Here's a little survey. This, located at the other end of this rod, is the throttle position sensor. Your foot still controls the throttle, but the computer knows what you're doing. This is information to and for the ignition system. This sensor measures the oxygen content in the exhaust gases. Here's the engine temperature sensor and the NOx sensor. Well, actually we don't have a NOx sensor here, but it's basically a microphone. There are more sensors monitoring just about every engine parameter you can imagine, and some cars will have more or less sensing, but it gives you the basic idea. The computer has three outputs. One goes to the ignition system to time the spark exactly. One goes to the fuel injector, pulsing it on and off rapidly to keep the air-fuel mixture right. And the other one goes to this thing. It's a small motor that allows the computer to fine-tune the airflow when your foot isn't on the pedal. See, the computer does more than just keep the fuel flowing at the right amount. For instance, if you turn on the air conditioner with the engine idling, it'll intercept that command, increase the idle speed a bit, then allow the air conditioner load to be added to the engine. If you hold the throttle all the way down while you're starting, it'll assume the engine's flooded and act accordingly. During warm-up, the computer knows to take some of its inputs with a grain of salt and to ignore the oxygen sensor entirely. It needs to be hot to work. If any of its inputs go defective, it'll light a warning light. It'll even describe the trouble to someone with the correct service tools. In the worst of cases, if it's unable to take command of everything, it'll set the gas flow to medium to let you drive it to the service shop. It's called the limp home mode. And because of where the injector is located on this layout, it's called throttle body injection. Since it replaces the carburetor directly, it and the computer and all the sensors are really just sort of a high-tech carburetor replacement. The throttle body unit still delivers gas and air down a fancy set of pipes to the individual cylinders. Two-in-port injection goes by several names. In this arrangement, each cylinder has got its own injector. And the opening and closing of valves to suck air causes the incoming air to pulse. It's a lot like playing the tuba. Now, each cylinder having its own injector allows the designer to optimize the intakes for the pulsing airflow, hence the name two-in-port. If you take two-in-port and add another computer wrinkle, you get sequential fuel injection. With sequential, each injector is fired only as its intake valve is about to open. It's a little more complex, but currently the high art of electronic fuel injection. So, computer and tons of sensors that would have been science fiction a few years ago. The result is better mileage and a non-polluting car that's fun to drive. The question was, why fuel injection? Why not?